All right, guys. So we are going to look at a couple of different things and decide if they are linear or not. So in my notebook, I'm on page 46, but I'm also going to be jumping to page 48 because I'm going to go back and forth between if it's linear, I'm going to put it on 46. If it's not linear, I'm going to put it on 48. Now, before we do that, we want to add a couple of titles. So the first thing that we're going to look at is equations. So let's do equations. Then we're going to look at tables. And then we're going to look at graphs. And same thing on 48. So we're just kind of putting these headings here and we're going to add to them. So equations, I'm running out of ink, tables, and graphs. I have to change colors here. That's fine. Okay, so first of all, equations. Now we did talk about this. I can tell that an equation is linear if the number is being multiplied to x and x has no power, like no little exponent, and x is not in the denominator. If that's not the case, then it's not linear. So if we take a look at number 1 over here, y equals 5x, that would be a really good example of linear because the x is being multiplied to a number, there's no exponent, it's not in the denominator. Number 2, however, over here, y equals 3x squared, not linear. So I'm just jumping back and forth and writing these examples down so that you guys have a lot to look at. Now the next one, number 3 over here, y equals 5 to the x power, definitely not linear. So that's another good example of not linear because x is up in the exponent. The next one, number 4, y equals x to the 3rd minus 5, not linear. X cannot have a power. If it has a power, it's not linear. So y equals x to the 3rd minus 5. It's all about that x, baby. Got to be looking at x. Alrighty, number 5, when I take a look right here, we got y equals x minus 7. That's linear because x is being multiplied by something. It's being multiplied by 1. Also, it doesn't have a power and it's not in the denominator, so that's all good. The next one, though, number 6 right here, y equals half x squared. Not linear. Not, because it has that exponent of 2 again. Can't have exponents. Right here we have y equals 1/3 to the x power. Not linear. Again, cannot have exponents. Even more so, you can't have x as an exponent. That's real, not linear. This one here, y equals x to the 3rd. It's got an exponent, not linear. And then last but not least, y equals x. That's linear. X does not have a power. It's being multiplied again by 1. So we have a couple linear examples. Just a couple more to throw at you. You could have something like y equals 1/3 times x. That would be fine. Or even a negative number, y equals negative 3x plus 1. That would be fine, all linear. One other nonlinear example that I just want to make sure we have is something where x is in the denominator. So something like y equals 2 divided by x would be not linear. Alrighty, on to the next. If we take a look at tables now, the way that I decide for a table, if it is linear, we talked about, right in here, we talked about if I add or subtract the same number every time. Now, really, I'm just looking at y, or the output values. So for this first one, we're jumping from 3 to 5, 5 to 7, 7 to 9, 9 to 11. So they are all going up by 2 or adding 2 each time. So that would be linear. Now, I don't know if you feel like you need to write this entire example out, but, and I already goofed it up, 3, 5, 7, 9, 11. But it's linear because we add 2 each time. Now going across here, this next one, we go from 0 to 2 to -4 to 7. What's going on? To -6. I mean, I added 2, then I subtracted 6, then I added 11. This is not following a pattern at all, not linear. So 0, 1, 2, 3, 4, and then we had 0, 2, -4, 7, -6. This has no discernible pattern, so not linear. Now the next one, again, just looking at the output values, -3 to 2 to 7 to 12 to 17. Well, the -3 to 2 is kind of weird, but 2 to 7, that's up 5. And then 7 to 12, that's up 5. And then 12 to 7, that's up 5. And if you go back and think about it, if I start at -3 and go up 5, I'd be at 2. So that is linear because you are adding 5 each time. So 0, 1, 2, 3, 4, -3, 2, 7, 12, 17. We added 5 each time. And then last one, so this one here, when I look at the outputs, we're at 1, then 2, then 5, then 10, then 17. And it's like, okay, from 1 to 2, we added 1. 2 to 5, we added 3. 5 to 10, we added 5. So they're not adding the same thing every time. They're not multiplying the same thing every time. It's not like I times by 2 each time. But there is kind of a pattern here, but it's not linear because it's not adding or subtracting. Like you could subtract the same thing every time. That would also be linear, but this one sure isn't. We got 1, 2, 5, 10, 17. There is kind of a pattern here because it's like +1, then +3, then +5, then +7. It's kind of like it's adding all the odd numbers, and that is kind of a pattern, but it's so adding odds, but it's not adding the same thing every time, so it's not linear. Okay, next we want to take a look at graphs. So I think these are the easiest ones. If I look at this first graph here, not linear. It's got to be a line. That's not a line. So an example of this graph here, just to do a little sketcheroo, it's kind of like shoop. Not linear. But the one next to it, totally linear. Cute little liney graph, like that. So adorbs. A couple more to try. If we look at this one here, not linear. Okay, so another little example graph. Kind of starts low, goes way up. The one right next to it, also not linear. It's no good. It's kind of doing this weird like swiggle thing. Boop. I think I got a couple more. Hey, that one I could totally draw a line through. And this one as well. Both of these are linear. So your linear equations, they could go up, they could go down. That's kind of what that dotty one is doing. Or they can go straight across. All linear things. Now, one other quick note, and I was going to do another example, but I just want to make a note about it. It's like if I'm reading a story problem, so with words, I can tell that something is linear if we are going to add or subtract an amount over and over again. Okay, so add or subtract an amount over and over and over. Like maybe if I'm making minimum wage at my job, I'm going to get that over and over. They're going to add that each hour I work. So that would be a really good linear thing. Or if I have to pay somebody for something per hour, like if I'm going to get my lawn mowed, I have to do that sometimes. You lose money every hour that they're there because you're paying them. A nonlinear pattern in words will be something is like multiplied every time you do it, or maybe divided. That's probably the best examples that we see in words. So multiply or divide an amount over and over. That's a prime example of not linear. So hopefully this helps with your homework, and let me know if you have any questions.